Okay. Welcome to the ARW discussion, folks. We got a lot of distinguished panelists here today, and one that's a little late showing up. And we hope to discuss heat treating, but if we don't, if our expert doesn't show up, we may talk about something else.
Hello, everybody.
And I got an announcement here. This is the last discussion for this year, and we won't be back until January. So you guys can spend the December doing whatever you want to do. All right. Mm-hmm. So I guess that's all the announcements I've got.
I was looking for the distinguished panelists. I don't see any.
I don't see him either. Maybe he forgot. Yeah. I don't have his phone number, so I can't do anything about it.
Yeah.
I know. Whoa! God, there he is, right there. There you are.
All right.
We were starting to get nervous.
looks like you ran all the way to the shop.
Yeah, I was down there packing up Harold's cup.
There you go.
Oh, good.
Happy Thanksgiving, everyone. Hope you all had a good Turkey Day.
Yep. Yeah.
Well, Stan, you're the star of the show today, and you're going to have to tell us about heat treating because I don't really know jack diddly about it.
Well, I typically work with one type of steel, which is 01, which is an oil hardening steel. I always get it from the same source. It's an online metal supply is where I buy my 01. They have fair prices, and the material is very consistent. I've only gotten one bad batch. Having said that, tool steel can come in with a bad batch, and you get bad results. You get things you don't expect, and you don't discover it a lot of times until you've already done all the machine work. After the machine work's complete and it's time to harden, and you harden it and it cracks or warps or does something you didn't expect, and your work is ruined. That's happened to me a couple of times, but at that point, if you have a lot of the material that was in the same batch, they'll come to you with certificates telling you what the batch number was and everything. If you've got enough of it, you can return it and get something new, or just maybe something happened on your end and try it again and see if the problem repeats. If the problem does not repeat, it might be something in your process that you did. But with 01, I found it's a very forgiving steel to work with. I'll explain my whole process when what I do with 01. I'll do all my machine work. I allow a grinding allowance because all my parts get ground with a surface grinder. I leave between 4 and 6 thousandths per side for grinding allowance of extra material, which means that part can't warp more than 6 thousandths or it's ruined. So and my parts are very thin. I make those little squares, as some of you guys know. So we go into the heat treat. We're done with the machine work. We've got an extra little bit of material on there to grind away after the heat treating is done, and we go into heat treat. Now, 01 tool steel wants about 1500 Fahrenheit, between 1500 and 1550, but the critical temperature on it is 1350. And what I mean by critical is it has to see that 1350 for a prolonged period. So I do a very slow ramp, and I make sure it transitions across that 1350 at a very slow rate, dwelling about 15 or 20 minutes within that 1350 on the way up to my actual hardening temperature. So I'll take it. I give it a 2-hour ramp time from ambient to 1550. That way, it's passing across critical temperature at a very slow rate. And after critical has been achieved, your molecular structure changes inside the steel, and your material becomes non-magnetic when it gets up to your 1550. and you want to quench it in an oil based on your parts. I've got a fast quench oil, which is good for blocks and heavy items. You don't have to worry about them warping or splitting or cracking. And then I've got a slow quench that I use for very thin parts. I've heard stories of guys using peanut oil because it's got good wetting and it doesn't boil very easily. So the meniscus of your oil and your surface wetting capability of your oil makes a big difference. And that's how they adjust the oils that I use. I've got like a 12-second quench, and then I've got a 27-second quench that I use. The 27-second is for very thin parts, and it's a very slow quench. So I elevate my temperatures slightly. I take it up to 1550 because it's going to take longer to quench it in that 27-second quench oil. And as quenched, I'm coming out of there on 01 between 62 and 63 Rockwell. And if you check it with a hardness tester, it's all over the place. You know, you'll get a 61 reading, and then you get a 63 reading, and you get a 64 reading. You know, the parts are just all over the place until you temper them. As soon as you pull them back with tempering, everything just stabilizes, and your numbers just blend right out. Now, there's a few things you have to do with your quench oil. I keep a steel block in that I throw in with my parts, and it's been in that oil so many times it's not even funny. So about 10 minutes before I'm ready to pull my parts, I grab that big steel block and I just swirl it around in the oil to preheat my oil. So you don't ever want to go into room temperature oil. You want your oil about 100 or 125. And especially on thin parts, you're going to shock them and kill them. So that's my entire process. And I temper down at 4 1/4, and that pulls me down in the 56 to 58 range. But my numbers, it doesn't matter whether they're 56 or 58, but I'll get 56 readings all the way across the board, or I'll get 58 readings all the way across the board. And it's very consistent after you temper. Tempering is really, really important.
How soon do you have to temper after the heat treat?
How soon?
Yeah.
I come out when I can actually touch my parts out of the oil and touch them with my bare hands, I go straight into temper.
Okay.
The parts are usually 125 or so.
Can you make a difference in how deep the hard metal goes down below the surface?
Oil hardening is about the deepest you're going to get, in my experience. The oil hardening is the squares, which are only a 1/4 inch thick. They get hard all the way through.
Yeah.
Well, look at Dennis showing off there with his vacuum chamber.
What kind of Rockwell you get out of that, Dennis? How hard is that stuff when you get done with it?
What's that?
What he's saying. I'm
Oh,
wondering how
I
hard.
don't know.
Have to wait for his comment to come back.
Yeah.
Yeah.
Hey, Stan,
So,
Yeah.
I picked up these 2 blocks the other day for nothing. I mean,
Yeah,
they're
I saw
like
your post on Instagram. Are they hard?
pennies for those things.
They don't look like they're hard.
No. So that's what I like what you're saying there. So I was thinking, since I got just a small oven, is doing them in the forge. Just heat them up in the forge. After I machine, I got to clean up the machining on them, get rid of all the scars and everything.
Who says they're made out of tool steel? You can't.
I don't know.
I mean, if they're 1018, they're not going to harden.
No, I guess I'll find out when they don't harden, huh?
Well, yeah. Then you'll have to carburize them.
Those don't taste like 1018.
Those are kind of big to carburize.
It doesn't taste like 1018 though. I don't know.
Doesn't taste like 1018.
No.
Okay. 67 to 68
I mean, there's no
Rockwell.
way
I've never
to-
got
well,
anything that hard.
There's no way to tell what they are, right?
There's no way to tell what the metal is. I mean, maybe do a grind test and see if you can see the sparks coming off of it.
Yeah. Yeah. Somebody did a lot of work on it.
Hey Chuck, I got a tip for you.
Yeah.
Go on a hidden place on it, and take your TIG and just strike a TIG arc on there for a split second, just a little pimple on there, something that you don't want to really ruin it. And it's the same effect as heat treating the whole thing, because the little puddle will quench real fast. And then
Okay.
try to file it. And
Okay.
if it seems harder than the rest of the piece, then you have a hardenable steel, and then you can go from there. You still don't know what kind of steel it is, but it's hardenable. If the little, don't add filler rod, don't add any filler
Yeah,
rod. Just like meld a little edge of the piece so that it quenches down and hardens. If it's hardenable, you'll see it in the file.
okay. I'll try
That's
that.
a good tip, Al.
Well,
Yeah, I'll try that.
that's
I
a
know a
good
little
idea.
So
All right.
do you get the ramp and soak times and stuff from the manufacturers from the material that you're using, or do you just test that till you get a good setting that you want?
Like I say, it's better to stay with the same manufacturer, get the same results over and over. That way you're not changing your formula in any way. And if a mistake is made and your parts don't turn out, then you start looking for things what you ask yourself, what changed, Did the material change? Is it something I did that's different? What changed? Anyways, as far as recipes go, there's a great website. It's called Hudson Tool Steel, hudsontoolsteel.com. And they've got a bunch of formulas on there for all the different steels. And I've done air hardening before too. And air hardening, your oil hardening, you use the lower temperatures. You use your 1500 and your 1550. But your air hardening, you want to go up to 1700, 1750 Fahrenheit to do your air hardening. And I've done that before with some success, and actually with some very thin parts too. And the first time we did it, all we did was pull it out and blow it down with an air hose while it was hanging on the wire and air quench it. And the parts warped like you wouldn't believe. So basically I ruined that part. The next time we had a piece, 1 inch thick aluminum plate sitting on the welding bench, and I had another aluminum plate ready to go. I pulled the parts from the oven, laid them down on the aluminum plate, put another aluminum plate on top of it, sandwiched it, clamped it, and then sprayed compressed air in from the sides. And the aluminum pulls the heat away from the part very rapidly, and it'll get a little bit of air around the edges, and it quenched in air, and it stayed straight. There were actually very thin, long, straight edges that I was making. We're making some knife edge, straight edge pieces out of air hardening material.
Interesting.
But that's been my only experience with air hardening. And the very first time I tried it, it was a total failure. And then after that, we tried the aluminum plate trick, and it worked.
Stan, I got a piece of air hardening right here and I don't know what type of air hardening it is, and I don't know what the manufacturer is.
What's the grade? A1?
I'm thinking it's A2, but I have no way of telling. I mean, there's no the only ID on it. It just says air hardening, and it's blue ink.
Taste it.
Oh yeah,
Taste it.
Yeah, Chuck says take a bite. Take a bite of it.
Yeah. So yeah, that came from an estate sale, and it was obviously it's air hardening tool steel, but what type or grade, I have no idea.
I think there's only 3 major grades of air hardening, and they all take the same methods. They all take the same quench methods and tempering methods. There's another chart that you guys should look at. I'll actually see if I've got it here that I can show you. But if you do a Google search for steel color temperature, there's a color temperature chart that's handy to have. I keep one on the wall right next to the oven, and it'll tell all the the blues and the reds all the way up to cherry red and beyond. Rick was talking about the spark test, and what you're looking for with that is the carbon in it. It's going to come out like a little fork when you're grinding it. You should see kind of an orange and yellow tracer with a little fork at the end of each spark. That would indicate that there's actually carbon in the steel for spark test.
Well,
if you don't mind grinding on the block a little bit, you might want to surface grind that block a little bit, Chuck, and see what kind of sparks come off of it.
Okay.
Just for the heck of it. to train your eye, take some crap steel, take some 1018, throw it on the surface grinder, grind it, see what the sparks look like, then put your block on there, grind it, and you should, if it's tool steel, it should be night and day.
Okay.
The way the spark tracers are coming off of that thing.
Okay. I'll try that.
Yep.
Thank
Well,
you.
look here.
One of the what? Oh, sorry. One
With
of
the air
uh,
hardening.
oh,
I'm sorry. I just got to ask this. With the air hardening, can you just take it and leave it out in the air, and or do you have to cool it down?
You should put it in front of a fan or something cooling it down as quickly as you can. But you don't, with air hardening, you certainly don't want to shock it by putting it in oil or water or anything like that. That's too much of a shock, because remember, your air hardening, your hardening temperatures are very much higher. You're up in the 1700s with that.
Yeah. Okay. Well, I was wondering. I had the wrong impression of air hardening all this time. I thought you just heated it and stuck it over on the shelf there and made it cool off.
No, I'd at least have a fan or something up there. Okay, here's that chart. I don't know if you guys want to take a look at that.
Hang on here. Let me find where it's stands. There you go.
There's the color chart based on temperatures of what your steel should look like. And I, like I say, I just keep that for tempering to make sure that the oven's working right. You know, and after you've taken your parts and they've hardened and you've quenched them and you've maybe given them a little bit of cleanup, and then you go into temper, use this to see what temperature your parts are getting to in the tempering process.
Yeah. I also happen to know that if it's a material that can be heated to where it glows, that's the color of whatever temperature you've got, regardless of what you're looking at.
Right. Well, that chart that I'm showing you there, that's available on, you can find that on Google if you just look up steel color temperature or steel temperature colors.
Hey Stan, I think you have to allow for some soak time as well, right? You can't just bring it to that color that you're shooting for and go
Well,
for
no,
it.
it'll overshoot very easily. You can watch your. You just want to make sure your oven's dialed in and make sure it after 20 minutes you've achieved that color. You know, after it's sat and soaked in the oven. You know, a lot of guys. I just use a yard sale toaster oven to do my tempering, because it's low temp, and I only want it for like 4 1/4. But the dial on those things is horrible. I've been threatening to put a PID in my little yard sale toaster forever to make it accurate, you know.
I was going to do that on one I
a
have.
$100 controller on a $10 oven.
Yeah.
I was going to do that on one I have for doing circuit boards for free flowing.
Right.
Never
Yeah,
got around to it.
I picked up a toaster oven off a bulk garbage day a couple of years ago. We have one in here in the town every year. People put big stuff out, and I snagged it. And yeah, I will not make the mistake of trying to goof around with tempering metal in the kitchen oven again, because my wife was not happy with me.
No, it stinks.
All the house reeked for days.
Well, after you've pulled them out of oil and gone straight into temper, you're burning all that oil off, and it stinks bad.
Yeah, I wasn't thinking about that one.
No.
Now you are.
I
Just a
learned.
little extra seasoning for that turkey.
I learned the hard way, but I learned.
I tried.
I'm single. No problem.
I tried heat treating some drill rod. Used a propane torch and got it all nice cherry red, and then dunked it in some oil. I don't know what kind of oil it was. And then I stuck it in the toaster oven. I think it got hard. It seemed harder. I didn't have stuff to test it with at the time. I do now. I might pull it out and check it and see what the hardness is on it.
Speaking of hardness, how many of you guys have those Tsubo-san files? You get like the little Japanese ones that give you the range of, within 5 Rockwell.
Oh,
Okay. I mean, I have a set. They seem to work okay. I wasn't sure what other people's experiences were with them as well.
They do work really well. I also ended up picking up a hardness tester.
Oh, nice.
In one of my classes, I actually demonstrate how to use the files. And then after I find the point where one skates and one doesn't skate and one does, then I go put it on the hardness tester, and I test a couple points and show them how to use it to verify the results. And so you see the files are actually telling you pretty close, pretty accurately. And
Okay.
so
I was wondering if anybody actually compared them against something real.
Yeah.
I like them. They're
A couple
affordable.
People brought up some good points. The color temperature crayons are good for your tempering. So your hardening temperatures are pretty forgiving. As long as you make critical, pass through critical at a slow rate, and then make your hardening temperature, if it's glowing red hot, it's going to get hard. It has no choice in the matter. At that point, it doesn't matter whether you're 1500, 1550, or even 1600. It's still going to hit. But your tempering temperatures have to be right on to get your final hardness that you're trying to get. So those color temperature crayons are pretty handy for that. And then another point Dennis just brought up is your hardness is based on your soak time per inch of thickness. And that guide that I told you about over at Hudson Tool Steel, they're going to tell you to add 20 minutes per inch of thickness, or it's all based on the part. So how long you soak the part after you've gotten to your hardening temperature.
is there anything wrong with letting it soak longer than that?
Not that I know of. I've walked
wasting
away
energy
from the oven and forgot about it for a couple hours, and then go back and go, oh shit, I forgot to take them out.
Okay, so you're just wasting money and electricity at that point.
You're just spinning the meter. Yeah, exactly.
Okay.
Yeah, Everett, you're talking about hardness files. What I usually do, I just use a new file that I keep for just checking the hardness. And I'm only talking about steels, including tool steel. They're all steels. And what you're shooting for after you hardened it and it's completely cooled down and you haven't tempered it. So I have a new file that like I said, it's not worn out, but I've used it so much for just testing hardness. It's probably starting to get worn out. But anyway, you can tell with a file, if it just glides right across it like glass, it's in the high Rockwell C, C 55, 63. If it cuts just a little bit, it's going to be below 50, 45. This is real, half guessing, but it gets it pretty close. If you're not like what Stan talked about, he's manufacturing a product. He's using a specific tool steel. He's got it all. He's got the heat treat ovens, and he can control every aspect. And you have to do that because that product will come out, as it was designed for. And that's what manufacturers do. And he's just going by the book, which is the right way to do things if you can. But like in a small shop, you could just, I flame hard. When I worked in the tool room, we had small items that we just flame hardened with an acetylene torch carefully and oil hardened it. And then, used crayons or I just with the blue color to temper it. And that was enough. And you can do that in a home shop. But, it depends on how important what your hardening is and what it's used for. And if one thing I might add, the critical temperature of all steels, like Stan specified the one for 01, but even if you're using, it has to have enough carbon to harden, like a medium carbon steel, tool steel, alloy. They all have a critical temperature, and if you don't have any way of measuring it, one way is with a magnet, because every critical temperature of every hardenable steel is different, but it'll become non-magnetic at its critical temperature. So like mild steel will be 1450. What Stan Steel 01 was talking about, I think he said 15 something. And at that point, it'll become non-magnetic. And that varies, but that's a quick way to check it.
Hey, Stan, have you ever tried tempering non-ferrous metals?
Like aluminum?
Yeah, aluminum, brass.
I've built ovens for customers that were actually annealing aluminum extrusions, because when aluminum comes out of an extruding machine, it's very hard, and they wanted it to be very malleable. They were making like window strips, and they had to curve them into oval for these windows that they were making, and the extrusions were 20 feet long, and we built them an oven that goes. It went up 22 feet long, but it was capable of 700 degrees. But I don't know how they used it. But I know it was capable of 700 degrees, and they would take it up to 700, then bring it down slowly in steps to anneal it. That's all I know.
So then you can actually harden aluminum as well.
The thing is, what's inherent with the extruding machines is they come out of the extrusion extremely hard, and to make them where they can form the material, they have to be annealed after they come out of the extruding machine.
Okay. So that opens up another curiosity. Find out if you can heat treat aluminum or not.
Well, I'm sure if you can anneal it, I'm sure you can take it back to a hardened state.
Yeah.
I know that 7000 series aluminum is quite hard. As you buy it, you can't weld it, but it's very hard.
Yeah, there's something about the oxidation layer on those that make them harder, if I'm not mistaken.
Well, an oxidation layer, they make grinding wheels out of aluminum oxide, for God's sake. So yeah, it's got to be pretty hard.
Yeah.
That's the thought.
Yeah.
So hey, a good resource, guys, if you haven't seen it, Mark LaCour from the Lazy Machinist. He has a really good heat treating video.
Mark LaCour.
Okay, thank you.
I was going to tell you on those files you're talking about. I don't actually even have to skate them when I'm testing materials with them. The ones that are rated for higher Rockwell, I can feel them biting in by just putting pressure on it. I don't even have to skate it. If it's when I put some pressure on it to move it, I can literally wiggle the table without moving it, and I do that till I get it down to that point to where it starts skating. So you don't even have to bite into the material. You can just put pressure on it. If it bites in at all, it will grip the material. It's that hard. Or it's less
that'll
hard.
probably make your files last longer too, because if you're skating them, you're probably rolling over that leading edge.
That's exactly why when I'm testing it, I do it that way, just to show the students in the class how I'm doing it.
I have two different hardness testers, and both of them have their use. One of them uses like a microscope with a reticle, and it's got a little snap punch with a carbide ball on it.
Yeah.
And I don't know if anyone's ever seen the PTC 316, but it's a nice little kit. It's portable, just fits in a drawer. And when you hit the snap punch, it'll make like a salad bowl in your part. Then you put the microscope over the part, and you actually measure the diameter from tip to tip of that little dish that you've made in the part. And in the reticle, it's got direct reading scale on there. It'll tell you how hard it is, and you can train your eye pretty good. It is subject to interpretation, to a human interpretation. The other one I have goes in a drill press or a milling machine. As long as you've got a solid base and your parts are nice and flat, and you want to do a surface prep on those, it actually uses a diamond with a point, and so it penetrates, and that's direct reading. That'll read on a dial. But every time you set it up, you use a test block, calibrate it, and it reads a lot like a dial indicator. You just bring it down. There's a stop collar that stops it from pushing down any farther, and you just read the scale. But that won't work on curved parts or anything that's got an irregular surface. Your parts have to be parallel and flat, and surface finish has to be very nice to get a good reading.
I've got one similar to that, except it's a self-contained unit. I think A-Bomb and I think Steve Summers has one similar to one I've got. You put it on the trunnion there and crank it up, and you bring your diamond tip into it.
Right.
You bring it down past a certain amount, and then flip a lever or whatever.
Right. That's a dedicated machine just for hardness testing.
Yeah.
That's ideal. That's ideal. I got such a tight shop. I didn't have room to have a hardness tester set up permanently anywhere.
I didn't either, but I wanted it. So,
well, I thought I wanted it too, till I brought one in, set it up on the table, and go, man, I'm going to use this thing twice a month, and it is just in the way. And I ended up turning around and selling it and buying those 2 little portable units, and I'm okay with those.
Yeah, I need to get some calibration pucks for it, and it specifically says surface hardness tester. Apparently, there's some different kinds for those, and this one you can put different weights in it, but it only has like a 15 kilogram set of weights in it. So you got to look on the scale and compare your reading to what it says.
Well, you can get the calibrated blocks from PTC pretty inexpensively if you want to get a couple of test blocks. That way you can see if you're reading correctly on your machine.
Yeah, that's what I need to do.
Yep.
I just hadn't done it yet. I figured for the makers, it's, we're not a production shop, so if we're getting, within a couple Rockwell C or something, we're probably doing all right.
I think that's all very nice and very interesting, but for the hobby shop, I don't believe it's worth the cost to buy a hardness tester and all this stuff. If, for example, you make a hammer, a hammer must be harder than the piece you hammering on, but not too hard. Otherwise, you're gonna chip the corners of the hammer. And the fun trick is if you make a hammer out of hot rolled steel, this the cheapest hot rolled steel you can find, some kind of piece of scrap, and you can make a hammer out of it, and you can harden it, and it works. Now, how hard is this hammer? I don't know, but for the hobby shop, it works. The trick is I'm gonna take a hammer. Yeah, okay, this is my hammer. Don't heat up the whole hammer, just this part. Yeah, I'm gonna say in inches, okay, half an inch, 1 inch, and you make it somewhere between dark red and red. Quench it in water, but not completely. Just 10 millimeters is enough. You quench in water, take it out. The red part, this part is still hot, red hot, is gonna temper the point you're hardening. And you see the blue line going up. And when the blue is about in the middle of your part, of this case a hammer, quench it completely in water, game over, and you will see it works. If you have a piece of spring steel, this spiral springs from trucks and cars, and almost don't find anymore now. But if you find a piece of spring steel, make it red hot, you can hammer it in whatever shape you want, make a chisel out of it. Yeah. Same. While you're working on it, the piece is soft. Yeah. Same. You want to harden the cutting side of your chisel you're making. Make it red hot, 1 inch red hot. Quench it in water, 5 millimeter, 10 millimeter about. Yeah. Wait that the blue line is, I'm gonna say, 2 inches high. Put it in water. Finish. Game over. And with this chisel, you can work in stone, in concrete, in whatever you want. And this is a trick I learned from my grandfather, who was a blacksmith, and he had his own workshop, his family business, and he sharpened chisels and drills for quarry working. For there was also a company that came to see him to sharpen drills, and they drilled holes in walls, and then they injected these products to make them watertight and all this. And that's the way he did it. He didn't have any hardness tester or oil or whatever. He did it all by eye, and it works. And for years and years he did it this way, and for years and years he had the same clients. So I suppose that they were happy with the results. So I think you want to harden something, don't go buy stuff that you're never gonna use, and maybe if you use it, you're not even sure if it works or not. Make something, harden it. If there's a piece chipping off, it means it was too hard. Yeah, if it bends, it's not hard enough. Try again. Of course, I'm only talking hobby shop. Yeah, this kind of work you can't do in a business. It's way too expensive.
I didn't spend a whole lot of money on my tester. I think I spent $250 on it. I found it used within about 30 minutes to 45 minutes of where I live. I felt like it was a decent price, and it was a dedicated tester.
Yeah, if you can have it for cheap, why not? It's always interesting to have. Yes.
Yeah.
Yeah. If you have a good occasion, don't hesitate. Jump on it and go for it. But if you don't have, don't panic. I made myself an extra large dividers in soft steel, and it was flat bar, it's the cheapest hot roll steel, and I hardened the points once, and I have this thing for years now. Of course, I don't use it every day.
Hey, Stan, there's something that you need to advertise your cups right now while you got a chance. I almost forgot.
No, the mugs finally came in.
You put me on your list, Stan?
Yeah, I got some here for you.
Okay.
We got to figure out how to get them to you economically. I mean, it's probably costs more to ship them than they're worth.
Yeah, that's
put it in a sock and hammer it real good, and then
it'll be a do-it-yourself kit. You have to glue it back together when you get it.
Make it Chinese puzzle. Yeah.
Well, I bought some extras so I'd have some left over after after Black Friday's over. Harold, I sent you an extra one for your wife.
What?
So if after Black Friday's all said and done, I'll have a few cups left over. I'll use them for Christmas gifts for my YouTube buddies and stuff like that. So
you ought to do some koozies up.
What is that?
Well, that's a koozie for my dog, but you could do those too.
Oh, okay.
Your dog uses a koozie?
No, but that's what one of my dogs looks like.
Oh.
I'm not afraid to show what I'm drinking.
Yeah.
I don't have a problem with that.
So Stan,
Today is the last day of Black Friday. If you guys want to get your hands on the CNC mugs, it says CNC fake machining on one side. Where's the camera go? And then on the other side, it's got the Bar Z oval.
Nice.
Yeah, I've got them for if you get 2 8-ounce anchor loops and a mug for $30 over on the website.
Okay, that's the Bar Z.
That's through the end of today. If you want to go to barzindustrial.com, get your order in. I'll get it out to you. International customers, it's honestly not worth the cost of shipping.
No, I don't think so.
No, but we can figure out a way. If you've got other people that are interested in them, I can get 6 mugs in a box, no problem, and it all ships for the same price. But shipping one mug isn't really worth it.
No, of course not. No. Plus, if it comes in, you pay for the shipping, but I have to pay again for customers.
For customs, right?
Yeah. So I think this one mug will cost about the price of 50 mugs.
Yeah, about 10 mugs or so.
Yeah, even more. Yeah.
Well, it is economical to use a forwarding service. I just had a guy in, I think he's either Sweden or Norway, not sure, but he ordered one, and I shipped it to Florida. and he uses a forwarding service out of Florida, and they just keep his stuff there. He orders stuff from the United States all the time. He buys stuff on, the US eBay and things like that, and he ships it all to this one guy, and that guy packs a crate for him and ships him the crate all at once. And he's got a bunch of stuff from the US, and he takes two deliveries a year, and that's just what he does.
That's actually pretty common. I hear that a lot.
They do it in Australia too. Bruce Witham does it all the time. I packed a pallet for him that weighed, that thing was 120 pounds, and stuff kept showing up to my door. I'd go out on the front porch. There's a big 6-jaw chuck, a big 8-inch 6-jaw chuck, and I go, I didn't order this. And then I get an email from Bruce. Go, hey, I ordered a 6-jaw chuck and had it shipped to you. Gee, thanks. So I'm packing a skid for Bruce, for his last load.
Heck, pretty soon it'll be rolling in a shipping container.
So that's what he does. That's what he does. Afterward, after I packed the last box for Bruce, I rolled it down to the port of entry here in Los Angeles, and he's got a contact down there he uses. I don't remember the name of the guy, but I just drop it off to him. I weighed it, measured it, dropped it off to him, and he sent it over. It took 4 months to send it over. For him to actually get his hands on it. It took 4 months for him to finally get his hands on it, but he got it, and he got all kinds of good stuff.
Do you count Canada as international? I'm seeing the international orders. Please contact us before ordering. Are we considered international?
Canada's pretty expensive too. I had a guy that ordered. He ordered an oven and an argon kit and some other things, and I just shipped it to northern Michigan, and I guess he was going to drive down and get it.
Yeah, I'm about I don't know how many hours from the border, so it wouldn't. Yeah, I'll pay for the postage.
I think he was pretty close.
Yeah, a lot of people here in Canada, if they live reasonably close to the border, like within a couple hours, they'll use a service like there's one called Border Bee, I think it's called, like basically holding services, get it shipped there, and then bring it across themselves. Now that we're actually able to go again, so I'll email you.
Well, we'll see if we can get something to you economically. What size box did I send you last time? Was it a medium flat rate?
He's sitting on it.
It's actually right here. It's from last. I haven't packed up from last night.
I saw you just barely got it open the other day.
Sorry, it's been buried. Like, you should see this disaster in my office. It's been buried.
Well, I saw the disaster on your video.
That's in the shop. This is the office.
I think that large flat rate box is like $45 to $50 to ship international.
Well, these will fit in a medium.
Yeah.
But if you got any other Canadian buddies that want a CNC mug, I can get 6 mugs in one of those boxes, no problem.
Okay. Well,
Or if you want some more anchor lube, let me know.
Yeah. Well, I'm sure it's good stuff. I haven't tried the tube you gave me.
Well, it works well on the more difficult materials.
Mm-hmm.
I use it on 304 stainless, 316 stainless.
Okay.
Inconel.
Yeah, I haven't tried Inconel yet. I haven't played with it.
It's magic on Inconel.
Okay.
Yep.
Yeah, this is it says large flat rate on it. So
I sent you a big one.
Yeah. So as far as
medium would be a little more economical.
Yeah.
Send me an email. We'll see what we can do.
Sure. Sounds good. Yeah, I don't want to hog the conversation here. So
Everett, do you guys get stuck paying the royalty also?
For, duties depends on what it is and depends on how much. Again, it used to be a lot easier to do trade back and forth, but then NAFTA got scrapped and now it's whatever they call it now. But it's a little more of a challenge now. But yeah, for coming this way, it's more of a challenge to get stuff. I've noticed it even with the eBay prices and different things, the exchange and the whatevers. It's like because eBay sometimes does their own whatever brokerage and all that sort of stuff, and the fees on that for coming to Canada went up too. So yeah, it's life. We pay more in Canada for everything.
You didn't pay anything for that stuff I sent you, did you?
No.
Because I labeled that as a gift.
Yeah. No, the thing is, it's for if you're doing like commercial type stuff, purchasing larger things out of the States. That's when you do that. The box you sent me was awesome. The way it was. Thank you for doing that. No, that one went I try to make it as easy on the recipient as possible. I'll list it as a commercial sample. Yeah, this came out great. Thank you for doing
Oh,
that. It's
okay.
just more along the lines of if I order something off of eBay or try to buy something out of a US company, depending on what it is and the tariff rates and whatever, things did change. It's just not that a few years ago, not that long ago. But that's just life, right? So it's when you cross a border with stuff. It'd be easier. Actually, you're allowed quite a bit. If I were to go to the States for a week and come home, I can pack a truck full of stuff if I want for myself. It just depends, right?
When we go down to Mexico, it's
Yeah.
it's usually $200 per person
Mhm.
of stuff you can bring back. It's it's usually bottles of wine or bottles of booze or
I was going to say that it's usually alcohol.
it's usually alcohol.
Yeah, they make really good vanilla down there. My great uncle was Mexican.
Alcohol and
and
cigarettes.
the vanilla was great. Didn't drink it, but it was good.
Their Kahlua is better than ours up here.
Really?
The stuff they export is watered down, so the coffee liqueur down in Mexico is way stronger, and we'll get that home. Everything else you can pretty much buy here.
When I was working in the evil polluting chemical plant, I had a boss brought in a coffee cup. I think he said it was ironstone. He says, you can drop this and and all, it's not going to break. And he started demonstrating. He's bouncing it on the table there and stuff. He went and got it full of coffee, and I was sitting there looking at it, and this little brown dot forms on the side and started dripping down. I told him, I said, I think maybe your coffee cup's not as indestructible as you thought. Oh, it was funny anyway. Sorry about that.
Ironstone, huh?
Yeah.
My wife just got some pots, Dutch oven, whatever for the kitchen, and they're pretty nice. They're cast iron, but they're porcelain coated, kind of like they do a bathtub.
Yeah.
So she won't even let me touch them. So
I don't blame her.
but I'm sure they're quite strong. But I'm sure the porcelain will still chip off.
I have
does,
some
she'll be
here,
pissed.
and you have to be really careful with it.
Well,
It's
I'll let her
expensive.
chip them. I'm not doing it.
Don't touch.
No, I ain't touching it.
I don't blame you.
Yeah, I'm allowed to do the dishwasher and stuff, but there's certain things I've got to keep my hands off of, because those are beyond my abilities.
On the
I have to
subject,
do everything myself, so
me too.
I'm very happy with it. Freedom.
Well, I do most of the cooking around here, but that's because of my current job description.
Yeah.
Hey guys, the final word on the heat treating. I got this out when I heard about the subject from Stan this morning. If anybody out in the YouTube audience, or we're a various group here. Some of us have heat treating experience, some just have a small shop, and some have manufacturing, whatever. But a good source is get yourself a copy of Machinery Handbook. You can find them on eBay. You can buy new ones, and they have a little section on heat treating. If I could get it in there, it's about 50 pages. About 50
Not that
pages.
little, Al.
It's a good read though.
No,
Yeah,
and
a little 50 pages.
but wait, something like that, or like I just showed you, and it'll tell you everything you need to know about heat treating, and we're afraid to ask. It'll tell you, from.
And if you get an old one, it'll teach you how to color case harden with liquid cyanide.
This is
Yeah.
19.
Cyanide.
I got a couple old ones.
Hey, we had cyanide hardening at Warner and Swayze, and the guy that worked there died.
Go figure.
That worked in that
No.
department. Cyanide hardening in the 70s. And
Was he pretty hard when he died?
It was
I said, was he
lived to
pretty
be a
hard when he
ripe-
died?
He retired and lived to be a ripe old age, but he died from that work. And now you can't find hardening, and it was chrome plating shop also together, which is another. Which is
One of the evil polluting chemical plants I worked in, we made 100% hydrogen cyanide. It was a liquid.
Right. Yeah.
Yeah. And we reacted with other stuff to make acetonitrile. But we had an outside sample pot for it, and there was an air suction on it going into the flare stack. And they'd bring you a bucket of ice with one of those little flasks in it. And you take that thing and pull the cork out, stick it up under the hood, fill it up with cyanide, well, maybe a little over halfway full of cyanide. You put the cart back in and work it down into the ice. And then you had to walk it all the way to the laboratory because you didn't want to be in a car if the cart blew out. And I remember I was up there with a guy that was a supervisor on another shift. The cart blew out of the thing while I was trying to get it in the ice, and I took off running upwind. And I look around, he's down on his hands and knees. I thought, oh my God, I'm gonna have to drag him out of there. And then I realized he was holding his breath, looking for the dang cart. I didn't just let that stuff boil off.
Wow.
So
Not
Stan,
far from where we lived, there was a shipyard, and for welding some of the parts, they had to preheat the parts. But of course, shipbuilding, very big parts, so they preheat. But the people that had to do the welding had to go on board to make the weldings. So they had asbestos blankets. And then in winter time, they were always very happy because everyone had cold in the shipyard. And these guys, they had nice and warm. And at noon, they eat their bread sitting on their asbestos blankets. That was normal, but it's not anymore.
Yeah, they didn't know.
Yeah.
So Stan, I want to set up an authorization course or class for the heat treat oven that I got from you. I'd like to get with you sometime and talk to you about what I need to teach these folks on how to use this thing without breaking stuff.
Okay.
Yeah.
Well, the oven's pretty hard to kill. So any mistakes you make are going to probably damage your parts, not the
Right.
oven.
You'd be surprised. I'd have some idiots that would open that thing up and take the air hose from the air compressor right next to it and spray in there.
Yeah, don't do that.
Yeah,
That'll
don't
harden
do
your
that. I
element.
read that one.
Your element will probably shatter.
Yeah.
Billy, do you have a coal forge or something, or even gas forge?
We have a complete blacksmith building. It's not near the heat treat oven. The heat treat oven is in the machining area, but the blacksmith building is actually a annex that's across the parking lot.
I've seen video of it. If you bring your students there, they will learn very quickly that hot metal is really hot. Yeah.
Yeah, I know.
And that you can do really nice and dangerous things with it. And
I don't do the blacksmithing teaching. That's somebody else.
No. But I mean to learn working with hot metals and hot materials. When you go to technical school, the first thing you're gonna do is not CNC. Yeah, we're gonna start by stand up and then walking fast and then running. So using ovens, it's perfect, but it's a learning curve. I think if you learn heating up stuff in a coal forge, you feel that it's hot, and you immediately feel that you better not play with it because you're gonna pay cash every error you make.
Yeah.
And then I burned myself lots of times, and came home completely black of coal dust because I played in my grandfather's forge. And then in the beginning, of course, we were making things and hardened things. And at the end, we were just burning stuff in his fire, so it's all part of the fun. But if you start, never worked hardening metals, and you start immediately with the expensive stuff, I'm not sure that's gonna work. For example, you have a machine, and the machine after a couple of years, it will be worn. But who is hurting the machine the most? It's the student, because he doesn't know yet. He has to learn to feel the machine, to listen the machine. You see what I mean? I think it's exactly the same with the oven. and the files and the hardness tester, they're not toys.
No.
You can play with it, and it's really fun. I think you have a nice time using all these machines, but you have to learn using these machines. And I'm not taking the students for idiots. I think it's nice that they want to learn things, but start from the beginning. Burn your fingers in a coal forge.
Hey, Stan.
And then you can burn all the rest in the.
Hey, Stan, what's the shipping on that furnace of yours?
Depends on where it's going. It's usually about $100.
That's not too bad.
You know.
I keep looking at them and drooling over them, and I'm looking at your webpage right now, and it says they're on sale for $8.49.
Click the sell button, Harold. Click it.
Buy
don't
it
know.
now. Buy it now.
Oh,
I got about 8 more left. You know, I don't think I'm going to sell out before Black Friday's over, which ends at midnight tonight.
I
Buy
was lucky
two,
to-
Harold.
you
Oh,
buy
heck yeah,
one
buy
too?
two.
Or, yeah.
We'll get one dialed in for tempering and one dialed in for heat treating. You just go out of one oven right into the other one.
Ah,
Just
They're
get the
beautiful
boss
machine.
lady to click it. Now
and,
you won't
and
be-
a third one for you never know what.
Yeah.
Well, now
That's a good idea.
I was watching last week's feed, and I watched part of your video on your Crucible Gold oven that you've
Yeah.
got. Where's and I had questions, and no one asked the question. Where's the thermostat or the thermocouple placement on that thing?
I
That
don't know.
That
I
is
don't know.
critical
If
on how
you-
that thing acts and reacts. And I just got to believe that's an inductive heater surrounding that little crucible, not heating elements. I think it's an induction heater.
It could be. I don't know, because if you open the lid of it and you look down inside, there's a little white finger sticking up about 4 inches on one side of it. And that's what the crucible keeps hanging on when you push it in there and pull it out. Now, what that little white ceramic thing is, I don't know. I do wish it was
Is it
further
a
over
limit
the
switch?
side.
If you pull the crucible out, does the heating element shut itself off?
No.
So it's
Nothing
not a
I know
limit
of.
switch.
No. I'm sure if they made a limit switch, they wouldn't make it all that much of a problem, because, you know, the darn thing, you have to really wiggle on that crucible to get it to let go of that finger, ever get it past it, you know?
Yeah.
It's
Well-
it's real pain.
Well,
I seen a video-
thermostat, your temperature sensing locations are pretty critical in an oven, on whether it's picking up radiated heat off of your parts, radiated heat off of your heating coils, or plain old air temperature. If you think about it, say you got a 100-degree Fahrenheit day out on the patio, and you take a piece of steel and set it out there in the sun on a 100-degree day, the air temperature is 100. What kind of temperature are you going to get out of that piece of steel sitting out in the
Oh,
sun?
it's hot enough to blister you, I guarantee you that.
Right. And that's radiated heat. So there's a difference between radiated heat and air temperature. The same thing happens inside of an oven, and your temperature sensing has to be able to pick up the radiated heat off of your coils or your heating source to be able to control it properly. If it's just sensing air temperature, it can't possibly control it right. You'll always be over temperature on your parts.
Well, I don't know. The guy that sells it talks about not running it too long, because you'll break the wire and one thing and another. I don't want you to reuse it over 3 hours. Then further into his spiel about it, and don't use it over 2 hours if you can. And the temperature that I'm seeing on the little display there, I don't believe that's centigrade at all. I believe that's actually, Kelvin, and it's I guess the set point doesn't matter what scale it's in. It's just a number. But if it's Kelvin,
I'm sure you can get your temperature controller to read out anything you want it to read. Centigrade,
Well-
Kelvin, Fahrenheit, whatever you want.
I don't know. I haven't taken it out of the thing to take a look at, but I just don't know what adjustments are available on it. I've got the temperature controller is a copy of a Japanese controller. It's not the real thing.
It's not the real Rex.
No, I downloaded the book for the Rex, and all the menu choices and stuff in the Rex are the one I've got are just like a subset, not the whole thing.
Yeah.
So changing what it thinks it sees as the thermocouple is just not going to work. I'm going to have to order a infrared temperature sensor that can read higher. My Horror Fright one just says over range when I try to use it.
900. Yeah.
You can also get those thermocouplers that you can use with a voltmeter, Harold.
Yeah, that's true.
Well, any thermocouple will work with a voltmeter.
Yeah.
I'll send you if you want me to email you the millivolt chart, I will. But based on the temperature is what millivolts you're going to get on your thermocouple.
Yeah.
Yeah, they work because I got one that came with my Blue Point meter, my automotive meter. It works great.
Yeah. All right, guys, we've had our hour. We're going to have to say goodbye to all these fine folks. You guys appreciate everybody showing up here to be on the panel, and I appreciate all the viewers that showed up to listen to us. And we'll see you again on the first Sunday in January. Okay.
Next year.
Happy New Year, everybody.
Happy Christmas.
Merry Christmas.
Merry Christmas. Happy holidays.
Happy New
Good
Year.
New Year.